Screen is visible, right? Right? Hello.
Yes, sir.
Yeah.
Yes, sir.
Maximum power transfer theorem. Okay. Today we are going to see this theorem where to see what is that maximum power transfer theorem, I am going to take one network, that is this is my voltage source, RS internal resistance and RL. Okay. Now this is RS, this is RL, this is voltage V, this is current I. Okay. Now we'll see what it states. The maximum power transfer theorem, the maximum power transfer theorem states that the maximum power is delivered from a source to a load when the load resistance is equal to the source resistance. Okay, here this is the definition. So you can see the maximum power transfer theorem states that the maximum power P delivered to the load RL from the source V, okay, when RS equal to RL, where from this figure I can write, from this figure I can write I equals to voltage source V divided by internal resistance RS plus load resistance RL. Okay, now power delivered to the load RL is equals to P equals to I square into RL, where you know this I is given by V by RS RL. So V divided by RS plus RL whole square into RL. I can write V square into RL divided by RS plus RL whole square. Okay, now to determine the value of RL to determine the value of RL for maximum power to be transferred to this RL, we are going to differentiate the load with respect to power. Okay, where I can write dP by TRL. This is a condition to determine the value of RL for maximum power to be transferred. We need to differentiate the power with respect to RL. That is dP by DRL is equals to 0. Okay, now differentiate. If I differentiate this, I'll get dP by DRL is equals to T by DRL V square divided by RS plus RL square into RL. Okay, now finally I'll get, if I differentiate this one with respect to RL, V is a common. Okay, now I'll get RS square plus RL square plus RL minus 2 RLRS minus 2 RL square equals to 0. That is nothing but, we can see here, these two will get cancel each other. RS square plus RL square minus 2 RL square. Here 1 RL will get cancelled from minus 2 RL square and RL square. I'll get RS square equals to RL square, that is RS equals to RL. Okay, hence the maximum power will be transferred to the load, hence the P is transferred, maximum P will be transferred to the load when my RS is become equals to my RL. This is the theory behind that. Okay, now how we are going to calculate the maximum power delivered to the load with some examples we're going to see now. Here just one tanker. Here the problem is given like this: find the value of resistance RL in the figure for maximum transfer and calculate maximum power and calculate maximum power. This question given. Okay, now the circuit is given like Okay, here 3 volts, 6 volt, 10 volt, 2 ohm, 2 ohm. This is also 2 ohm. This is a variable resistance, there is load RL. This is a question given. They asked find the value of resistance RL, this RL, okay, for maximum power transfer and calculate the maximum power. Fine. What are the steps we are going to follow here? Now, first step, remove this RL. First step, I'm going to, guys, 1 minute. I'm getting a call. Okay. Step is RL. Okay. Now, guys, am I audible to you guys?
Yes, sir.
Yes.
Yeah. Why?
Yes, sir.
Because I'm going to ask a question in middle. So please be attentive. Okay. Here, first step, I am going to remove that RL. Then I am going to mark those terminal as A and B. A, B, plus minus. Okay. Now I need to calculate the open circuit voltage, that is VTH here. A and B is there. I removed that. Okay, I named those terminals. I marked potential plus. Then I need to calculate VTH. These points. Okay. Now I need to calculate RTH seen from the point, this point. RTH. Okay. Now how many loops are there?
One.
One loop, because I opened this. Okay, here I'm going to mark this one as current I. Okay, if current is flowing into, I'm going to mark this plus minus plus minus. Okay, apply KVL for this loop. Yes, apply KVL for this loop.
Minus 2i.
Minus 2I.
Minus 2i.
Yes, minus 2I.
Minus 6
Minus
plus 3 equals
Minus
0.
6
minus 6
Plus 3
plus
equals
3.
0.
plus 3
plus
equals to 0. Final, I'll get I equals to how much? Means minus 4I, then minus 3 by 4 equals to 0. I equals to minus 3 by 4. That is minus 0.75 ampere. Okay. Next step, writing the equation for VTH. VTH is equals to plus, see, I will write here equation for VTH. Here plus to minus. Minus 10 or plus 10?
Minus 10.
Minus
Minus
10. Then
minus
here.
10
Here plus 6 or minus 6. This one you
plus
leave this one. Why?
Plus
Because
6.
here current is not, there is no voltage drop. Okay. 6. Here current is flowing, right? That is current I is flowing in here. So
plus 2
plus
2i
or minus?
plus
plus
Yes.
2i.
Plus 2i, then plus minus, minus or plus?
minus
Minus VTH is equals to 0. Okay. Now we know I is minus 0.75. Okay. Plus 6, that is okay. Then plus 2 into minus 0.75 is equals to VTH. That is VTH is equals to minus or plus 4
5.5 minus 5.5.
minus 5 point,
5.5.
Minus 5.5.
yes, minus 5.5 volts. This is VTH. Okay. Now calculation of RTH. What we did in Thevenin's theorem, we replaced all the voltage sources with the short circuit, current sources with the open circuit. Here also I am doing the same. I am going to replace the voltage sources with short circuit to calculate my RTH from seeing from the points A and B. Okay, here I short circuited this. Okay, now tell me three resistances. This is open. See, current is dividing into these two resistance. The current is same for this two, right? So parallel, two in parallel. For calculating RTH, this two are in parallel. Okay, two in parallel plus this parallel will series in this two. How
3.
2 into 2
Three.
by 2, 4.
3.
Yeah, this is 1. 1 plus 2, this is 3 ohm. RTH is 3 ohm. Okay. Now, calculating, see, find the value of resistance RL. This is resistance. Resistance RL. Okay. We know we calculated RTH. RL for maximum power. According to the maximum power transfer theorem, maximum power will be transferred to the load become equals to the internal resistance RS, that is RTH. Here I can write RL is equals to RTH equals to 3 ohm. I can write like this, right? Now I need to calculate P maximum, that is power maximum is equals to, how we are going to calculate this power maximum? What is the formula for that?
I square RL.
Yes, I square RL. I square RL. Not only I square, IL square. This, see, before that, we'll show you. Here, IL is equals to VTH divided by RTH by RL. Okay, we know this one. Here, RTH plus RL. That is VTH divided by RTH plus RTH. I can write like this, right? Okay, for maximum power. Then VTH divided by 2 RTH. Okay. I can write VTH divided by 2 RTH. Understood? This one. Yes, no.
Yes, sir.
Now P max IL square into RL. Now we know this IL is this. Okay, now I can write VTH square divided by 2 square, that is 4 RTH square into RL is nothing but RTH. I'll get VTH square by 4 RTH. This is the formula for maximum power P max, that is VTH square divided by 4 RTH. Okay, now tell me what is the P max?
2.52 watt.
Point
52.
P max is equals to VTH square divided by 4 RTH. VTH is 5.5 square divided by 2. I'll get V max as 2.52 watt. Okay. We'll see another current source. This one is voltage sources with current source. V max equal to VTH square divided by RTH square and RL equal to RTH. This one is very useful in solving this type of problems. Where now next question is find the value of RL for maximum power transfer. Okay. The network is given like this. Once again, I am going to tell you that please note the problems where you are facing the difficulties, in the sense any problems, note down, then email me or WhatsApp me. I will solve those problems. Okay, this is a problem given 1 ohm 8 volt. This is RL. Okay.
Excuse me, sir.
Yes.
Sir, skip. I can see only previous screen, sir.
Now, Kushla, turn off the video. Guys, Kushla, are you able to hear me?
Yes, sir.
Yes, sir.
Okay, leave that. Screen is visible, right?
Okay, ma'am.
This one.
Yes, sir.
This is given as 5 ohm, 4 ampere, 5 ohm, 10 volts. Here, one voltage current source is given. This is a variable resistance. First step is what we need to remove this variable resistance and mark those points open circuit A and B. Now calculation of VTH here. Okay. Now tell me how many loops are there without removing this RL?
3.
3.
3 loops are there.
Yes,
After
sir. 2,
removing
sir.
RL, no, before, after removing it will become as 2. Before removing 1, 2, 3.
3.
Okay. Now I'll remove this one. Yeah, this is point A, this is point B. I need to calculate VTH here. Okay. Now how many loops?
2.
2 loops. Okay. One loop, second loop. This is I1, this is I2. Now these two loops sharing a common current source. Then what type of problem it become?
Next time.
Super mesh, right?
Yes, super mesh.
Yes, we need to write the equation for super mesh. Now here I can write I2 is in same direction of 4 ampere. I1 is in opposite direction of 4 ampere. So I can write I2 minus of
Minus
I1
I1 equals to 4.
equals to 4. This I'll call as equation 1. Now I need to apply KVL for outer path, this outer path. Always remember we are not going to apply a KVL to the current source. Here this current source is common for both the loops, loop 1 and loop 2, where I1 is in opposite to 4 ampere, I2 is in the same direction of 4 ampere. So I am writing this current equation, this branch current equation as I2 minus I1 equals to 4. Now I need to apply KVL in the outer path here like this. I need to apply KVL in this outer path. Okay, now apply KVL in outer path. Yes, tell me. Plus to minus, plus
Sir.
8.
Plus 8
See,
minus
first
1
1
I1.
minute. I will mark those. Plus minus, plus minus. Yeah, plus 8 minus
I1
minus 1 I1
minus 5 I1
minus 5 I1
minus 5 I2
minus 5 I2
minus 10
plus to minus 10 is equals to
equals 0.
0. Yeah, 1 and minus 5 minus 6 minus 5 and then minus 2 equals 0. Okay, now I can write minus 6 I1 minus 5 I2 equal to 2. I call this equation as 2. Now solving equation 1 and 2, I'll get I1 and I2. Tell me the values for I1 and I2. Simple.
So I1 minus 2 I2 2.
I1 is minus 2, yes, correct.
I2 is 2.
Minus 2 ampere. I2 is plus 2 ampere. Okay, now write the equation for VTH, this one. Yes. Write the equation for VTH. Always remember the voltage across the parallel is the same. If you remembering that point, voltage across the parallel circuit is always same, right? Correct or not? At least say yes.
Yes, sir.
Yes, sir.
Here, whenever I am applying or writing the equation for VTH, I am to consider only this circuit, this one. So I can write the equation for VTH as minus to plus, plus 8, plus to minus, minus 1 I1, then plus to minus, minus VTH is equals to 0. I am writing equation in this path only. Okay, now we have calculated I1 and 2 ampere. What will be the A1 into minus 2 VTH equals to 0. VTH equals to
10 sir.
VTH is
10 volts.
yes
10, sir.
10. Yeah. Now calculate the RTH by seeing from this end. RTH. For that, what we need to do? We need to short all the voltage sources. Current source open. Okay, this is open. This is short. Short circuit. Short circuit. Yeah. Now this 5 and 5 are in series. See, don't confuse with this. I am removing this voltage. Open circuit the current source, short circuit the voltage source. Okay. Now this 5 and 5 are in series. See here. 5 and 5 are in series. That is, this is equal to 10 ohm. 5 plus 5. Okay. In parallel with 1 ohm. Because here current is
0.9.
dividing. Okay. Now RT 10 in parallel with 1 ohm. That is point, how much?
909.
Yes,
9.
0.909, that is not 0.91 ohm. Correct? Now, see, now I got VTH, I got RTH, then I got RL. What is the value of RL? What is the value of RL?
0.91, sir. Same.
Yes, we are calculating the RL for maximum power. So, RL is equals to RTH. That is nothing but 0.91 ohm. This is 0.91 ohm. VTH is given as, means we calculated as 10 volts. Okay. Now, calculate the maximum power. Maximum power. What is the formula? Tell me. P max is equals to, yes, VTH square divided by
4
4 times
RTH.
RTH.
4 times RTH. VTH is 10 square divided by 4 into 0.91. P max,
By 4 RTH.
yes,
27.47.
24,
27.47.
yes, 27.47 watt. This is,
27.
yes, P max is 27.47. Fine. Now